5 and then put a colon over it, and then equal, then we plus enter into it. So you can see the answer is suppressed. Now it is stored in A, but it is not now it is not displaying as a result out in command window. So just by putting this colon, you can easily suppress the answers just for the reference. Because now I don't want the answer. What I can do, I can so A is equal to 5 and sorry, A is equal to, let's say, 10, B is equal to 5. I put a colon over it. That means they are not displaying the results now. They are just storing the values in the A and B. But I want that C is equal to A plus B. So C is equal to A plus B. When I entered, I press the enter button and not a colon. So what I can get, I get the answer that C is equal to 15, because I don't want to display these results for A and B. I want to display result for C only. Then that's why I haven't put their colon. So that's why this colon is very, very important. Why important? Because this can increase your computation speed also. Because whenever, every time when you put a colon over it, it is just storing it, not displaying it. By just displaying also, it is capturing some type of memory into it, and that slow the computation power of it. So that's why colon is very, very important as far as MATLAB is concerned. So switching on to the power plant. These are the similar things which I have discussed there. Now, how to create a vector? So creating a vector, we have a three different way. That means we can initiate the vector. Let's say I want numbers like 1, 2, 3, 4, 5. So I can create that number just by writing it. No, I can simply do it by a method. So if I can say that a variable A is there, I can say I want a number from 1 to 5. So 1, I can write 1 and write a single colon and 5. So and enter. So you can get the number 1, 2, 3, 4, and 5. Which means that you can directly create a list of numbers, array of numbers, just by using this colon. This colon is very, very useful for incrementing it. Otherwise, you can also write, let's say I want a number from 1 to 10, but with the increment of 2. So the notation is like this. That means 1 to 10 with the increment of 2, I can get this number. So 1, 3, 5, 7, 9. So you can see. Okay. So this colon is basically by default it is taking the value as 1. Okay. When I put nothing in between 1 to 5, it means that it is automatically taking the value as increment as 1. Whereas in this case, it is taking an increment of value of 2. So whenever you want to define some other number of increment, you have to just mention the number in between them. So you can see the values. Now the another way of creating the numbers. Let's say I don't know the increment. I don't know the increment. So what I can do, I can have a number called linspace. That means linearly spaced numbers I want. LINSPACE, linspace. It's always start with the small letters. Do not use the capital letters. It always start with the small letters. So linspace is a function which basically creating a number of variable linearly spacing numbers. How? Let's say I want a number from 1 to 5, and in between 1 to 5 I want three numbers. So I press enter, I get 1, 3, and 5. That means, which means that I want a number from 1 to 5, and how many numbers are required? Three numbers are required. Then we use a linspace command. So linspace is a command basically creating a vectors whereby you can give a number of let's say positions are how many positions or how many numbers are required. Then you can easily use your linspace, linearly spacing variable. So it uses a equation of line to generate a number. Similarly, if I say I want a number linspace, I want a number from 1 to 100, and I want something 10 numbers in 1 to 100. I press it, so you can see randomly it can, or linearly spacing, it can generate a number from 1 to 100 and how many numbers are there? 10. So that means 1, 12, 13, and up to 100. So this is how we can create a number list by making use of linspace. Similar to the linspace, we have a log space also. So I simply say, can simply write log space. So it is a linearly spaced numbers, and this is log space number. Based on the log spaces, based on the logarithmic value, it can generate a number, and I put here. So again, it is creating a number with the power of 100, means So you can see the variables now. You can see here. So like this. So 10, 10 is to power 12, 10 is to power 2, like this. So it is generating a number such that it is 1 to 100 with the from 1 to 100 it is taking a log space of it and then generating only 10 numbers. So that is the how you can create a uh, this vectors with the help of linspace, or you using this number, or using this method. So this is a three important ways by which you can simply create a vectors. Okay, so this is a vector form. So simply it's just taking 1 raised to power means 1 raised to power uh, sorry, 10 raised to power 1, 10 raised to power 2, like this. So it is something like this. So next is a vector. What is a vector? Vector is basically a number of elements in a row or a column. So if I say it is a row, so I can simply say one like this 1865. I have typed this. So just in a square bracket, whenever you write some number by a space, by leaving a space, you can see either a comma, either here you put a comma over it or a space over it, you get a row, row matrix. Okay, you get a row matrix out of it whenever you put a comma over it. But whenever you put a colon, whenever you put a colon over it, then it will give you the next row. Okay, so this is the row matrix you will get, and for different row you have to put a colon over it. Like in this case, you write a 158, then put a colon. That means this is the second row, and this is the third row. Okay, likewise. So this is the second row, and this is the third row, and this is the first row. So in this way, you can get a multiple rows. Otherwise, you will get a single row whenever you write one vector. So I can show you. So let's say if I want to input a vector, so what I can say, capital A is equal to 1, 2, 3, 4. Okay, so put a square bracket over it, and I want to display the result, so I just put the enter, and then you get 1, 2, 3, 4. You get a row matrix. Similarly, if I want to know if I want a column matrix, column row, column, so I put a transpose over it. So what is the symbol of transpose? Just put a transpose like this. Okay, yes, you can see here I have put a transpose over it. You can see now it become a column now. So it is a column matrix. So just to convert a row and a column, you basically use a transpose matrix, and that's what I have got. Okay, so I think this is okay up to now. Or any doubt till now?
No, sir.
Okay. This is a row vector and a column vector. But if I want a matrix, so what I can say, I type a 1 space 2 space 3. Now next row, if I want to generate a 3 by 3 matrix, so I put a 1 space 2 space 3. Then I can write my 5 space 8 space 9. Then again I want a third row. I put a colon over it, and then 2 plus 2 and 5 plus and 7. I put a square bracket closed. So when I put my enter, so you can see I get a 3 by 3 matrix. So you can see how we get 1, 2, 3 is the first row, then a colon. That means it goes to the second row, that is 5, 8, 9. Then I put a colon again, then it goes to third row, so that is 5 and 6. Also, if I put a space, I can also put a comma over it. The means the same. Okay, either you put a space or you put the comma, you get the same answer. Okay, so whenever you are moving in a row, whenever you're moving in a row, basically you are putting either a comma or a space, you get a row. But when you put a colon somewhere, this semicolon somewhere, uh, you get the next row. Okay, that is a one thing. Next, so this is the same thing which we have discussed. Okay. Now next we have some ready-made type of matrices now available with us, like zeros, ones, rand. Rand means random number generation. Like let's say we have a is equal to zeros. Zeros is a command line which you basically remember, or otherwise you can you making use of help command, you can easily get it. I want a zeros matrix of 3 by 3 matrix. I put the enter over it, and then you can see 0 0 0, we get a 3 by 3 matrix. If I want a row matrix, I can simply put a 3, and then it become a 3 by 3 is simply also. But if I want some non parallel matrix, that means I want means 3 comma 5, I have to put the number. So, but if I want a square matrix, you simply put a 3 over it, and then you can easily get it, or a 5 over it. Similarly, I can have a matrix like ones. Let's say B is equal to ONES ones. I put a ones and put a 3 comma 3 again, and but you will get a 1 by 1 3 by 3 matrix of 1 1 1 element. Okay, that is basically a ones command. So we have this ready-made type of matrices also. So you can easily get. So what is A? A is 0 0 0, B is 1 1 1. Can you add this A plus B? No. Why? Because we have the size issues, that it is a 3 by 3 matrix, whereas this is a 3 by 5 matrix. So whenever we want to add a matrix, the size should be comparable. That means the size should be equal. 3 by 3 can be added to 3 by 3 itself. 4 by 4 can be added to 4 by 4 matrix. That simple rule which we basically follows by manually also. Same rule applicable to MATLAB also. So that is the one thing. Next, concatenation of matrices, which means that you can combine two matrices also. Like you can see in this, x is equal to 1 and 2, y is equal to 4 and 5. We have a two vectors, and z is equal to 0 0, means 0 vector. So you can combine this vector also. That means you can have a vector like this, 1 2 3 4 and 5, just by writing x comma y. In the first row they can add. If I want like this, 1 2 4 and 5 downside, but I can write x first and then colon and then y. Okay, so every time remember, this is basically for the column. Okay, for the next column, this is basically for the next column. And sorry, next row. Okay, always remember, this is for the next row, and this space is basically for the same row and different columns you can get. Okay, so this is how we can get. So this is concatenation of matrices. This is called as a concatenation of matrices. Means whenever you want to combine two matrices, you can use this thing. Next is indexing. Now once you have created some matrices, let's say A is equal to 1 comma 2 comma then 1 comma 2 is the first row, and 5 comma 6 is the second row. So I just enter it, A is equal to 1 2 5 6. But I want to know what is my A of 3. A of, let's say, 2 comma 1. A of 2 comma 1. So A of 2 comma 1 will be similar. That means 2 means row, that is 2 row, and 1 is column, the first column. So what is that element? 5. Okay, so when I press enter, I get the answer 5. Same we use in MATLAB, in manually, where we use. So 2 comma 1 means 2 row, second row, and the first column. So the first number is representing the row, and the second number representing the column. That is the thing. Okay, so A 2 comma 1 means 2 second row and the first column, that which strikes at number 5. Similarly, if I want to know 2 comma 2, so it will give us the answer 6. So that is the way you can assess the variable. But if I get 2 comma 3, I can get an error now, because what happens is it is exceeds the array bound, which means that it is basically the 2 by 2 matrix, but I mistakenly I entered 2 comma 3, but it is not existing. The 2 comma 3 element is not existing now. 2 comma 3. So that's why you can't assess it, and that it will show you the error like this. Okay, so there is one command. Okay, I will tell you later on, but now I have to tell you. CLC stand for clear command window. CLC stand for, CL means clear, and C for command window. Because everything is now, let's say, populated. This command window is populated. So what I will enter, simply type CLC and then press enter. Now everything is removed. Okay, this is very simple to remember. CLC, okay, CLC, and enter. You can see every command window is clear. Now what happened is command window is clear, but if you see in the workspace now in the bottom left corner, uh, 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 the variable still existing. Okay, space is now okay, but the thing is variable still available with us. That means if I write a here and press enter, I get the matrix again. So that means clearing the command window doesn't mean that variable has been removed. It doesn't. It only means that uh, it only means that the space is clear out of it. Now the thing is how to clear these variables now. I don't want these variables to be in my database. So what I can write here, clear, clear, and with space all. Clear all means all the variables are now has been removed. Okay, which you can see in the workspace now. You can see it is populated with all the variables now, A, B, C, answer, and all everything. Just putting a clear all command, you press the enter. So what happens now? Now you can see the workspace variables has been removed now. Okay, so that is two commands, very important commands, clear all and CLC. Now I have to clear the clear command windows, so I put a CLC over it and press enter. You can see again the command window has been now clear. So that is a one thing. So this is indexing. Okay, indexing means when you want to find out some variables, okay, numbers from it. So this is how you can do. Okay, first and second like this. So likewise we do it in Excel na. Same thing we did in the MATLAB. Okay, but the indexing of the MATLAB always start from 1 comma 1. It never start with 0. Okay, 0 comma 1, 0 comma 2. That is not possible in MATLAB. Okay, indexing always start with the 1. Okay, it always start with the 1 comma 1, or it could be 1 comma 2 like this. Yeah, 2 comma 1. But it cannot be, indexing cannot be 0. Okay, it cannot be 0. Indexing cannot be 0. There is nothing like 0 in the indexing part. So again the same thing, assessing assessing the variable. Let's say I want to assess the complete line out of it, this line. Okay, I want to complete assess it. What I can write here is uh, it's something like 1 2 3 4. So it is fourth row. So I can write like this, fourth row in a parenthesis, fourth row, and then comma. But I want every column, 1 2 3 4, four column. So I want all the column. When I want all the column, I put simply a colon out of it. When I want all columns, in the column end I can put my a colon out of it. So this is how you can 4 comma colon. That means I want a fourth row. This is a fourth row. So I write here 4 comma. I want all the columns. I want all the column means this one. So this basically this is exhibiting every column na, column 1, column 2, column 3, column 4. So whenever I want all the column, which means that I put a colon over it like this. Okay, that is how we can assess matrix rows. I mean row, if I want to find out the complete, I want a complete matrix row, I just simply a colon in the column part. Okay, in a column part. This is a column and this is representing the row. So I want a fourth row, but I want all the columns out of it. So in fourth row, I want all the element. That means I want a whole column of it. Let's say if I want only this part. Let's say I only want this part, 0.7 and 0.6 part. Let's say I want only this part. So how can I assess it? I put element 4 over it. Okay, fourth row, but I want only second and third column. So what I can put here is 2 second, and then 2 2 3, and then second. Okay, so this is how I can assess my variables 0.7 and 0.6. 0.7 and 0.6 are in fourth row. That's why I have written 4 here, and but it is in second and third column na. So I put here 2 2 3, 2 2 3 column. So this is how I will get my answer like 0.7 and 0.6 like this. So this is how I can assess my matrix rows and matrix column now. Similarly, we have a matrix column. Let's say I want a third column. I want a third column, but for every row, want to complete every row I want. So what I can do, I can write, because I want all row, so all row means I put a colon, comma, and I want only third column. So I can put here 3, and thus in parentheses, when I press enter, I can get this answer. Okay, so this is how we can get a matrix column. I can assess the matrix column. Similarly, let's say if I want only these two numbers, let's say I want only these two number, zero point 0.2 and 0.6 number, if I want. So how I can assess it? I want only 0.2 and 0.6. So that means I want first, second, third, fourth. So I want third and fourth row. This element is in third and fourth row. That means 3 to 4. This is 3 to 4, comma, and because this is third and fourth row, and which column? This is third column bracket. So this is how I will get answer as 0 0.2 and 0.6. So this is how I can assess my matrix columns. So this is the same thing which I have just written there. Assessing multiple rows and columns, you can assess simply in the ways in the same rule. See, all these are basically you are means applying in the coming sessions. Okay, in the coming session, in this week, whenever you are having different sessions, you are going to use these indexing and these types of rules there. Also, in addition to it, you can also change that. Means what it means is, let's say I have a matrix like this: 1, 3, 6, 5, 8, 9. 697. Let's say this is a vector, a matrices. But mistakenly I have written 8 here. Let's say 8 here. So, but I don't want 8. I want a number that is, it is 8 is what? 8 is 2 comma 2. I want that 8 2 comma 2 should be 10. I just press the enter. You can see now. Now a, initially the a 2 comma 2 is 8. So I can change the value a to 2 comma 2 to 10 simply. Okay. So what will happen in a matrix is, you can see a 2 comma 2 is replaced by the 10. So this is how you can substitute different values also. You can substitute different. Let's say if I say putting a 3, I can okay, a3 comma 3, you can replace it by 7 by something number, so you can easily do it by the same way. Now the next thing is operators. Operators means we have different types of operators, like we in mathematics we have addition, subtraction, multiplications, division, power, and complex conjugate response. So this is this is the same way we can apply in MATLAB also. This is what I have shown you in the previous slides. CLC means clear command window. You can see in the previous slide, this is all there in the command window. When I put a CLC over here, every command window is clear now. Similarly, you can see clear variables also. So initially we have a number of variables here, A, B, C, D, E, F. When I put a clear all variable, clear all command, every workspace is cleared. Now next is matrix operation. Whenever you have a matrices, two matrices, let's say one is called as A matrix, one is the B matrix. Both are 3 by 3 matrix, and both are 3 by 3 matrix. You can simply add it. Add it means one variable is added to 3. Okay, this variable added to 5, then becomes 7. Okay, 2 means 3 variable will be added to 2, like we did in the simple manual MATLAB, simple manual matrix addition. Same thing rule applicable to MATLAB also. You just simply adding element wise element. Addition is element by element. Okay, but what about the multiplication? Or similarly subtraction also. So it become 1 minus 3 become minus 2. You can see here 2 minus, this 2 minus 5 become minus 3. Okay, 3 minus 2 become 1. So likewise, this is subtraction. This is again element by element subtraction. You can see here product. How you multiply the two matrices? Just by first this row by this row, you get this element 22. Okay, then then you multiply this by this row, you get this 27 element. Okay, like we did in the simple calculation, manual calculation. Similarly, if I multiply this row by this row, I will get a 45 number here. Okay, so similarly with the second and the third row, you get this numbers. So product is something similar to what we do in the manual part. You just multiply the element, first row by first row, then first row by second column, first row by third column. Likewise, you get this by second row by first column, and so on. So this is the product. Okay, and what is about transpose? Transpose, which means that you just transpose it, as we did. Row become column and column become row. Okay, so just you put a symbol over it. I have already shown you. You put a symbol like this, colon symbol. Okay, a transpose symbol over the top of the matrices. The matrix will be transposed. Now next is element by element multiplication. Element by element multiplication means, like we have, like let's say we have a vector. Okay, you can, you whenever I put the element by element, means that let's say I have a vector like this, 1, 2 and 3. Okay, another vector is 2, 4 and 5. Okay, and if I say this is a matrices and this is b matrices, so if I write like this, a dot multiply, okay, b. So this is a symbol for element by element matrices, which means that you can multiply these two matrices element by element, which means that 1 by 1 into 2. Okay, first element with the first element, it become 2. 2 multiplied by 4, it become 8. 3 multiplied by 5, it become 15. That means you can also multiply these two vectors also just by putting a dot and multiply. Okay, so this is a symbol for element by element matrices. You can see here. So this is element by element multiplication, element by element division, and element by power. Okay, these three are commonly used for element whenever I want to do element by element mathematical calculations. Okay, so we have to put a dot over it and then multiply, and then you can easily do the element by element matrices. Then we have a operational operator that is relational and logical. That these are some of the logical, that is relational operator also, where relation between the two matrices are there. Okay, so if I say one element is there, two element is there. If I say 1 is equal to 2, so this means it will give you 0, which means that it is not equal to 1 is equal to 2. I can show you in the MATLAB also. So if I say 1 is equal to 2, it will give logical 0, which means that they are not equal. Similarly, 1 is equal to 1, then it is called as logical 1. So this is the logical operators, which just give you, if I say 3 is greater than 5, it will give us 0. Again, logical 0, which means that the relation between them is not true. So when it is not true, as we did in this true and false relation. So it becomes 0 and 1. So if I say 6 is greater than 3, so it will give you 1. So that's how that's a way, you can see a logical relation between these two. Now, so this logical operator we use in this flow controls: if command, for, while, break. So these are the commands for if command. Let's say if is a condition, if condition is satisfied, then this MATLAB command will be executed. Other, if it is not satisfied, then it goes to else if. Then this command will be executed like this, as we see in this C programming or Python programming. These are just different formats, but the overall concept is same. So if, else if means if this condition is satisfied, this command is executed. Otherwise, if this condition is satisfied, this command will be. But if this command is executed, it directly go to end part. Okay. If any of the commands is executed in between them, let's say if this condition is satisfied, directly it go to the end command. So if any of the conditions are satisfied in between these, it directly go to the end command. You can see a number of examples here. If a is equal to 3 and b is equal to 5, so we have some commands here and then it go to end. Or else if I apply some other rules also, so that can be also possible. So all these three are somehow the same thing, but in a different way, by making use of else if command or else command. Similarly, we have a for loop. For loop always start with the 4 f4 by writing 4, then you have to decide how many times this set of lines has to be executed. Okay, so we have number of lines here, and how many times this line has to be executed, that we will give it here. And this is what basically I is equal to, it can be something like 1 to 10. Okay, like we did in the creating the array. Basically this is creating an array 1 to 10. That means 1 to 10, it can run from 1 to 10. Okay, 1 to 10 times means this set of lines basically run for 1 to 10 times. So initially it is 1, then after executing this command, it will now become I become 2. After executing this command again, it becomes 3. Similarly, after executing this command, it becomes 4, and so on. So this is how this loop, for loop actually works. So it all depends upon this indexing. How many times you want to run the program, that all depends upon this indexing. This is a format for some. Uh, this is a format for different for loops that you initiated this for loop I is equal to 1 to 100, and thereby some commands are there, and then it is end means here, because every time you have to use this command for and end, where this end ends, basically that lines are executed now. So every loop is something here, is means moving here itself. Okay, so this is all. I can show you some. Okay, our last is while loop. While loop, in while loop, basically you don't give some fixed iteration is there. Not a fixed iteration, but it all depends upon the condition. Until unless condition is satisfying, the loop will run. Okay, loop will continuously run until unless this condition is not satisfied. Once this condition is satisfied, you come to an end, and then you come out of this loop. That is the difference between while and the for loop. For loop have a fixed number of iteration. If you say 1 to 10 or 1 to 100, that is fixed number of iteration it can do. But while loop can do up to until the condition is not satisfied. Once the condition is satisfied, until the condition is not satisfied, it comes out of the loop and your program has been completed. So that is a basic definition of while loop. I will show you one example also in the MATLAB itself. So let's say I have a program this like this, program one. So this is an editor. This is a program editor. Okay. You can see I have written one program just to say A is equal to input. Input is basically when the user want to enter.
Hello,
So
sir.
let's say if you want to enter some number, okay, not this is not fixed, but you want to the computer will ask you
Your
to
background is
enter the
too
number.
noisy.
You have to use this command like input in bracket. You enter
Your,
the statement
your background
inside
is
the
too
gun.
noisy.
So this is input.
Yeah,
This to display
yeah.
means this will display that is display this line. Okay, the
Ha-
day is this display the line. Now
Hello,
this is a switch command,
Dr. Simon,
or this is switch
Dr.
command
Simon,
means
sir.
if I run this command,
Hello, Dr.
this is a
Simon,
run
sir.
option. If I push a button, run over it. So what will happen? It is asking enter a number for a day. If I say if it is 5, so it will give me the answer like the day is Friday. What actually happened in this case, when I enter the 5, so it comes to the switch command, and I it here the day is equal to it become day is equal to 5. So day 5 will come here, and we'll see which case it basically fits. So case 5 is what, this Friday. So this is how you can use this command. Switch is similar to if command also. So just by entering this command, you can simply uh, run this program. So what is the way to run this program? So you just put a run button there over there. You click on there run button, and then it is asking now enter the number of a day. I say 2 and press enter. So day 2, the day 2 is Tuesday. So definitely day become 2, and case 2 it become case 2. The case 2 is Tuesday now. So that this is a simple way. Second program is basically the for loop. Let's say I want to find out the factorial. What is a factorial? Factorial is what let's say if I want to n factorial, or let's say 5 factorial. So if I want to count 5 factorial, it becomes 5 into 4 into 3 into 2 into 1. This is a very basic programs. Okay, 5 into 4 into 3 into 2 1. So I want a number like firstly 5, then I want a number 4, then I want a number 3, then I want a 2, and then 1. So I want this in to be run in a loop. So I what for that, what is the program? So, and I enter the number, let's say, again, this is a enter the number. That means I want, for what factorial I want. Okay, factorial for 5, factorial for 6, which factorial I want to know, that will be into input by this command. And then this fact will become n. Fact is a variable, initialized variable. Then for loop starts here. For I is equal to 1 to n minus 1. 1 to n minus 1 means, because fact n is equal to nothing but we are repeating the fact n variable. Fact n will be equal to fact n multiplied by I. So fact n is initially is n. N means 5. So that means it become 5 multiplied by I. I initially is 1. When it comes to the loop, I is 1 now. So it become 1 here. 5 into 1, and it again go back to the for loop. Then I become 2. So 5 into this, the fact n become 5 now into 2. It become 10 now. The fact n now become 10. Again it goes to the for loop again. I become 3. Now put here 3. Initially it was 10 into 3 become 30, and so on. So like this for loop continue until it become n minus 1. That means 4. N minus 1 is 4. So 1 to 4 it runs. So whenever I run this program, you can see if I press enter and input the number, I enter the 5. So factorial for 5 factorial is 120. 5 factorial is 120. So you can see easily here the factorial of the number is 5. So 5 into 4 into 3 into 2 into 1. So, so what actually happens is it's basically a loop which is basically uh, moving until these iterations are completed. So this is how we can program in a simple way this for with the help of for loop and while loop. So this is the program which I have shown you is a M file. We can call it as a script file. So what you can how you can get it just by putting here. You can see in the left top corner button, new is there. Whenever I press a new, this script file is open. The script file. Now you write your command here. A is equal to 5. B is equal enter. B is equal to 10, and then C is equal to A plus B, and like this. So you can write your program. Okay, this is a program, and this program is saved as a script file. So when I run this script file, you can get your result in the command window itself. Okay, so this is a M file. This is called, when I save this file, when I let's say I save this file, you can see here it is saved as a .m extension. So every file on the MATLAB is saved as a .m extension. That represent a MATLAB file. And now you can save it by some test program. I can say test, and then where you want to save, and then save it. And so this program is now saved. So when I run this program again, what I can see, C is equal to 15. Okay, so because I have entered A is equal to 5, B is equal to 10, and then C become equal to A plus B, and then you get the C is equal to 15. This is the MATLAB program basically which you are using for computing for different scientific problems or engineering problems. You can write the program. So this is M file. Okay. Similarly, we have certain other files also, like you can have a function file uh, inline, and this is alpha at the rate. So let's say I want to compute. This is very interesting topic of inline and the. So what is the basically meaning of inline? Let's say I want to compute A is equal to inline. So A is, or let's say F is equal to inline, and I have certain equation like I write equation like x square. X square means like this: x raised to power 2 plus 2 multiplied by x plus 1. Okay, and then apostrophe close and then enter. So this become F is equal to inline. Inline means now it become a function. I press the enter. Now this become a f of x is equal to x square plus 2x plus 1. Now I want to evaluate this function at certain point. Let's say f at 5 kitna hoga? That's f of 5. So f of 5 will be what? That 25 plus 10, 35 plus 1, 36. So it becomes 36. Just what it has been done here is I just substituted the value of x as 5, and then now you can substitute any value f of 100, let's say. You can get the answer 1000, 10,201. So this is a way you can write your function file. Okay, this is a ready-made function file. You can simply, you can also have a, you can also write, let's say f is equal to inline. This is a syntax for it. Okay, in parentheses, like I write x square plus y square, like equation of a circle. I press a enter. Now this automatically, this function now becomes a function of two variables, x and y. So what I had to do, I have to give the coordinate of x, that is 2. I have to give the coordinates of y, let us 3, and I press the enter. What you will get 13, which means that 2 square plus 3 square. That means 4 plus 9, you get the 13. Okay, so this is an inline function. This is called an inline function. You can create any type of function with you, because why we are using this function, or why we are uh, why we are using this inline function, because this function you are using in some in toolboxes of the matlab. Directly you have to use these toolboxes. Okay, so there you have to write this inline function. Another way of writing this inline function is anonymous function. What is that anonymous function is, let's say, I same thing I can write. Let's say d is equal to, at the rate, I can have again x comma y. Okay, and I simply write the equation x square plus y square. Okay, so now you can see d is equal to, at the rate means at anonymous function. Anonymous function is a function of two variable x comma y, and then you write the equation. Again, if I want to find out the value of 2 comma 3, let's say, at value of d at 2 comma 3, I can get the same answer, 13. So there are two different ways, the same thing you can do. Okay, either you use the inline function, or you use a anonymous function. Okay, you can get the same answer. And this is very, very important as far as your toolboxes of MATLAB are concerned. Okay, so that's why this is very important point to discuss in this in the basics of MATLAB. So this is the base. This is how basic function formula and then anonymous function is used. Then again, if I say function file, okay, function file. If I want to write a function file, that is this is very, very important. Function file. Let's say I want to make a function file of addition. So what is the format of it? I write a function first. Whenever I want to draw a function, write a function file, I write a function, and then what is my output? Let's say I want the output as sum and multiplication, and that, for that I have to give, let's say, I gave it name, I give the function name as math. Okay, and for that I have to input a and b. Why a and b? Because sum is nothing but a plus b. Okay, and mul will be equal to what? A multiplied by b. Okay, so this is, so now you have created your own function. You have created your own function, and that function name is math. It can be any name. It can be any name. I can give it a name like Ram. Okay, so this function name, that means this is a user defined function. You can create your own function. The function which I have just seen, inline function. Inline function was a function which is basically a ready-made function given by MATLAB itself. But this function which I am creating now, that is a function, a user-defined function. A person had made this function. Now again, I save it, Control S. You have to save this file by the same name which you have given the function name. Okay, so I have given the RAM now. So RAM, so I have written the RAM here, and then I save it, save. Okay, now how I could run it? No, you can't run like simply like just putting a run over it. No, because it is not, it will not run like this. The function file will not run like this. You have to, firstly you have to go to the folder where you have saved this file, and then, so RAM, I can write here, because my function is saved in the same folder. Na, I am currently in the current folder, and that is RAM here itself. So I can write RAM in bracket. If I write 3 comma 5 and then enter, so what I will get answer as 8. Why? Because I have I haven't given the output कि हमें which output I want. So by default it is giving only the first output. But if I want both the output, so how I can write it? I can simply write it like this. Uh, let's say A comma B, okay, square bracket will be equal to RAM of 2 comma 3, okay, in bracket close, and let's press enter. So what you will get, A is equal to 5, which means that the sum is equal to A plus B. So in the firstly it is A, that is sum, and B is basically the multiply of this. So that is a feature of this function file. And this function writing a function file is very, very important, because it works on the global variable, whereas a M file works on the local variable. Global variable means local variables means the function file works in a local variable, which means that if I given the value of A and B, it is, if I now ask what is A, uh, sorry, so if I run this program now, since I have entered the value of A, because this is the output of A, but if I want a small value of A, it is showing unrecognized function, because it is not recognizing the variable, which means that all the variables which is used in this function file are remain itself inside the function file, and it is not a global variable, it is a local variable. It only works inside the function. Outside this function file, there is no value of this small a and small b. Okay, that is the difference between a function file and the script file. So this is a function file. Strings will be covered later on with some more commands, because we are going out of time. So we have some basic commands also. PWD, print working directory, demo, whose means who is basically, you can see who is the, who will tell you the information about the variable, whereas whose will tell you the detailed information about the variable. Whenever you type, so if I say who in bracket A, so it must be a scalar, because A it is not recognizing. Okay, it is not recognizing. If I say A is equal to 5, A is equal to 4, small a is equal to 4, B is equal to 10, and now if I ask who is A, sorry, who and A, so your variables are A, means who space A, who space and capital A, your variables are A. But if I want a detailed information, I can write whose A. So it will give us a detailed information. You can see A is a variable, size is 1 by 1, bytes it will take 8, and class is double. That is the difference between who and who. Who and whose. Who is basically tell you about the variable, कौन variable है, which variable it is, and either it is a variable or not. And whose tell you the detailed information about the variables. So that is all about who and whose. Similarly, clear and clear we already covered, colon covered, percentage sign whenever you write, want to write some comment over it. Let's say if I want to say something about this sum, so I can write here a, a percentage sign and write this is to calculate the sum. Okay, so whenever you want to put some comment, sorry, whenever you want to put some comment, you have to just put a this percentage sign before it, and then this is not executed now. Okay, this become a comment now. You can also make certain line as a comment. Okay, just putting a percentage sign over there. Whenever I put a percentage sign over there, it becomes a comment line. That means it is not executed. Okay, so this is very so whenever you want to see a percentage line, if I say this is multiply, okay, this is multiply, so this is a basically a comment line. Okay, so this is done. So you can take a help from help command. Okay, if you want to know more about the command, because there are so many commands, I'm not able to cover all the commands. You can take a help of this help desk also. So this is how you can take a help. You can just type your command which you want to learn, and then you can get all the information about it. Thanks, and thank you.
Thank you, sir, for sharing your valuable insights with us. Moving forward, I now take the honor of introducing our next speaker, Dr. Anjani Kumar Mishra. Dr. Anjani Kumar Mishra is an assistant professor in the Department of Electrical Engineering at NSUT Delhi. Prior to this, he was an assistant professor at Thapar University, Patiala, Punjab. Before his tenure at Thapar University, he worked as a doctoral research fellow in the Department of Electrical and Computer Engineering at the University of Michigan, USA from January 2020 to February 2021. Dr. Mishra completed both his MTech and PhD degrees in the electrical engineering at IIT Delhi, finishing in July 2015 and January 2020, respectively, with honors. His PhD thesis received the Best Thesis Award at IIT Delhi, Distinction in Doctoral Research 2020 Award, and the second prize in the IEEE IAS USA Thesis Contest 2020. Including these, he has the recipient of many other awards like Corps of Engineers Prize 2022 by IEI India, Young Scientist Travel Award by DST India, Research Excellence Award by IIT Delhi, etc. He earned his BTech degree with honors in Electrical and Electronics Engineering from AKTU Lucknow, Uttar Pradesh in 2011, where he was recognized as the best technical student. Recently, Dr. Mishra was honored as an IEEE senior member and serves as an associate editor for several Wiley and Springer journals. He has authored over 78 publications, including 20 IEEE transaction journals, and holds 6 granted Indian patents. His research interests include power electronics, electrical machines, renewable power generation, microgrids, smart grids, and electrical vehicles. With this introduction, I invite Dr. Anjani Kumar Mishra to deliver the session.
So, my screen is visible.
Yes, sir.
It's visible.
Yes,
Hi.
sir.
Yeah. Okay. Okay. Hi. A very good afternoon to all, and thank you, Jaswi, for this wonderful introduction of myself and providing this wonderful opportunity to interact with you all and discuss some crucial and important concepts related to MATLAB and Simulink and their applications in providing efficient solutions for planning and designing smart cities, particularly with more inclination towards the electrical system because I am from the electrical engineering background. So I will discuss more about the electrical circuits and electrical solutions to build a smart city. So thank you, Simanjit sir, for giving such a wonderful and insightful lecture. So building upon the discussion by Simanjit sir on MATLAB and especially different useful commands that could be used to solve the complex problems and modeling of the systems, and how you use these tools when integrating with the Simulink enables us to model, simulate, and validate complex smart city infrastructures in an effective and reliable way. So my topic is also very closely, my discussion is very closely related to the previous discussion, and we'll discuss about the basics of MATLAB and Simulink and its amalgamation to provide the solution for the smart cities in different aspects. So myself, Dr. Anjani Kumar, so from the electrical engineering background. So first, let's see what is the difference between the MATLAB and Simulink. So Dr. Simanjit sir has discussed very insightful commands and command windows that is used in the MATLAB to solve the equations to make the system more easy. So there is a basic difference between MATLAB and Simulink. Simulink is also the part of the MATLAB, the whole package. Simulink is the part of the MATLAB. So basically, MATLAB, in the MATLAB, we do the high level programming and numerical computing environment. We can do in the high computing environment, and it is used for mathematical modeling, algorithms, and visualization, particularly. And we can write the script M file using the M files. We can write the different script functions and solve them to get our desired output. It is best suited for the data analysis, machine learning, optimization of the different things, and signal processing. So you can just simply write the commands and you can optimize and you can use the different signal processing commands to make your system reliable as well as the efficient, and you compute easily and get the desired results. On the other side, in the Simulink one, it is also just closely related to the MATLAB. It's basically uses the graphical environment with block diagrams. Block diagram means whatever you have written in the command window, that is also same as the block diagrams, but
Changing.
the MATLAB has one provision to provide a ready-made blocks for everything. Okay, behind that one there could be the programming is there, but if you want
Sir,
some, yeah,
sir, your PPT slide is not changing. You're on the first slide.
okay, just wait. So I am
Otherwise, keep it in the slide. Or
okay, okay, just so now it's changing.
not changing, sir.
Yeah. Okay. Fine. So that is the basic difference between the MATLAB and Simulink. Simulink directly use the block diagrams. Okay. And Simulink is ideal for control system to design the power electronic dynamic systems because there is a ready-made block is there for everything. So you can directly pick the block of whatever you desire to design the system and just simply connect. Okay, so there is a just drag and drop usual modeling, and this Simulink is best system level simulation and real time testing. So in the coming time in this lecture, we will take one very simple example how we can convert a AC signal into the DC one by using the MATLAB, particularly the Simulink tool. Okay. So both MATLAB and Simulink are equally needed to make a system. So MATLAB provides algorithms, scripts, and numerical tools, whereas the Simulink provides system-level modeling and simulation environment. And both are tightly integrated to set parameters. Like Simulink runs simulations and MATLAB processes the result, and you can get the final desired result, whatever you want. So like for example, in the MATLAB, you just design a control algorithm, and using the Simulink block diagram, you implement and simulate the control system with plant models. So both the tools are equally crucial or needed to make a complete system. Okay. So like for taking the example of Simulink and SimEscape. SimEscape is also the part of the, you can say the sub part of the Simulink. Both have the there. There is a little bit difference between the Simulink and SimEscape. In the Simulink, you have just take the block that is black in color, right? If you want to identify which block you can use in the Simulink tool and which block use in the SimEscape, you just pick the black boxes for the Simulink one and the green or the blue color boxes for the SimEscape. What is the basic difference between these two? Like Simulink, when you want to model and test control logic, algorithm, and signal flow. Whereas in the SimEscape, you want to simulate the physical behavior of the system with real world environment. So what it's mean? It's mean that if you want to integrate the electrical system with the real-time physical behavior, you need both the blocks to make your system, both the Simulink versus SimEscape. So if you want to simulate some physical systems like damper, spring, mass, you have to take the SimEscape block. That one is green in color or blue in color. Whereas on the other side, if you want to design any electrical system that is not in physical nature, you have to pick the black color boxes. We will see later how will you take that blue color and the black color boxes are there. But basically here, the thing is that if you want to make a Simulink model, you should have to take the black boxes. And if you want to make a SimEscape, you just need to take the green color or the blue color elements from the MATLAB library. So in practice, they are used together. So in context with the smart city solution with the MATLAB, there are a lot of things we have to design using the MATLAB and to provide the solutions for the smart cities, to to focusing on the integrating and co-simulation in smart city system. Because if you design, let's suppose if you design any system, any equipment and anything, so before going to implement into the real field, before going to implement into the real system, you should have to test in the MATLAB environment first, because it is not very efficient or effective way to directly implement any design system into the real time. Okay, so before going into the real time or before going into implement into the real field, you should have to first test into the MATLAB and Simulink environment, so that you could get all the informations regarding how it will work, what are the amount of current, voltage, or other parameters would go if we implement into the real field, and we can rectify all the problems if you could get any problem in the MATLAB and Simulink environment. Okay, so like the machine learning applications or optimization techniques, power electronic converters, intelligent control system, all of you have to design using this MATLAB Simulink platform. So it is very relevant to do MATLAB and Simulink system design uh, before going into the real field or implement into the real field. So how MATLAB and Simulink help smart cities? So there are a lot of things that is required to make a city smarter. Like we need smart energy and power grids. So using the MATLAB tool, that is the command window tool, you can forecast renewable generation using machine learning, like programming into the machine learning or artificial intelligence into the command window. You can forecast the generation of renewable like solar, wind, and other renewable energy sources. On the other side, using the Simulink, you can model the microgrid, or you can say the smart grids, energy storage systems, and converters. And together, using both this MATLAB and Simulink, you can design a complete, efficient, and effective system. Like example for smart energy and power grid simulation is you need smart meters, you need power electronic converters, you need optimization of energy distribution in the smart city. So by using this MATLAB and Simulink tool, you can easily first simulate or analyze all the aspects of your system in the MATLAB and Simulink environment, and then after you can go into the real field and implement your concept. The second thing we need for the cities would make the smarter is like smart mobility and transport. So using the MATLAB tool or command window tool, you can analyze, you can make a traffic flow analysis, route optimization, artificial intelligence for autonomous driving. Whereas using the Simulink, that is the block diagram tool, you can simulate or you can design the dynamics of electric vehicle, control of electric vehicle, and to make it charging stations like DC charging, AC charging, slow charging, fast charging. Okay, all you can design using this Simulink block diagram. So, and together with this MATLAB and Simulink, you can get a different numbers of application for the smart cities, like to develop a smart charging infrastructure, traffic signal optimization, and to build a intelligent transport systems. The another thing you need in the smart city is smarter infrastructure and buildings. So using the MATLAB, that is the command window, you can analyze the data from the IoT sensors like temperature, occupancy, etc. On the other side, using the Simulink block diagram method, you can design the high voltage AC control systems, renewable building integrations, and different other things could be there. So combinedly, both MATLAB and Simulink, the applications is like energy efficient building designing for the smart cities. You can also analyze the predictive maintenance of elevators, escalators, lighting using this MATLAB and Simulink tool. Another thing you need in the smarter cities is like smarter water supply and waste management. So by using the MATLAB tool, you can design data-driven water demand forecasting, leakage detection using machine learning. Just write a command in the command window, just write a program in the command window, and you can analyze all these things. On the other hand, in the Simulink one, using the block diagrams or using the circuit diagrams, you can design the hydraulic system modeling, pump motor control, and other things. So combining with both the tools MATLAB and Simulink, the applications could be like smart pumping stations to develop the smart pumping stations, to develop the waste treatment plant automations, water quality monitoring, etc. That could be the possible applications of this combined MATLAB and Simulink tool you can design before implementing into the real world. So basically, MATLAB is used for algorithms develop, data analytics, and optimization, whereas the Simulink tool is used for system level modeling, simulation, and hardware integration. Okay, so together they provide a complete ecosystem for designing and validating smart city solutions. So just to build a uncontrolled and controlled rectifier, we are taking one example how we could change the coming AC supply in our home, because in our home we have a 220 or 230 volt AC supply, single phase AC supply, but we have the gadgets like mobile, other battery charging systems, and that needs the DC output. So how we could convert this coming AC signal into the DC one, and the best way and the most optimized way to convert this coming AC signal into the DC one is the diode bridge rectifier. You just need 4 diodes to design that one, and you can get the DC supply from the coming AC supply. Like your mobile charger. Mobile charger or mobile battery is needed 5 volt or 10 volt of supply, maximum of 5 volt or 10 volt of supply. And for that one, you first convert your coming AC 220 volt supply 50 hertz into the DC one, and then controlled one to get the 5 volt 10 volt, because you have the different gadgets and the ratings for the different gadgets is also different. So there is also need of controlled system, not only uncontrolled one. Okay, because as you all know that the output of the uncontrolled rectifier is 2 Vm upon pi, where Vm is the coming AC voltage peak of that one, root 2. Like 220 is coming, so 220 or 230 into root 2 divided by 3.14 and into 2 Vm by pi. So that is fixed. But that will not serve your purpose, because you want 5 volt supply, 15 volt supply, 20 volt supply. And for that case, you need the controlled rectifier. Okay, for getting the controlled DC voltage, you need controlled rectifier, and for the uncontrolled system, that whatever the supply would come, you will be satisfied for that one. That then just need to implement the uncontrolled one. So I am just saving the MATLAB thing. So this screen is visible, this command window.
Yes, sir.
Yeah, okay, fine. So Dr. Simanjit sir has discussed about how to write the command, what are the different command systems are there to write, to compute the mathematical things are there. Here, we will see how we can use the MATLAB Simulink blocks to design any system. Okay, so the first thing, just go to this new. The plus sign is there and scroll it down. You see that in the last, there is a Simulink model is there. So you just simply click to Simulink model and this window will come. Okay. So we want to make our new system. So we need the blank model for that one. So just click on the blank model. So the blank model is there. So what elements we are needed to make it diode rectifier that is uncontrolled? Simply 4 diodes, 1 AC supply, and 1 load. The load could be RL load, could be the RLC, could be the RLE, but most of our load in our homes are resistive plus inductive. Okay, like LED bulbs are there, all machine loads are there. So we always consider this loads as resistance plus inductance load. So we need to design the diode rectifier, and we want to analyze how much diode ratings, how much load is required, how much the current will flow if we give the 220 volt or 100 volt supply from the AC one. So all these things we can get by just simulating here, okay, by the Simulink applications. So we need first we need a AC voltage source of 100 volt or 200 volt. So here is a library browser is there. So you just need to double click this library browser. Here number of toolbox and block sets are coming. So you can simply search from this search box. We want AC supply. So just simply write AC supply. So here is coming AC voltage supply. AC voltage supply. If you want DC one, then just write DC supply. But here we want AC supply, so we're writing AC voltage supply. Just enter that one. You are not getting. Again, right, there is some spacing problem is there. AC voltage source. Okay, so it is coming. So not the AC voltage supply. Here is the AC voltage source. So like if you want a DC voltage source, like DC source or DC voltage source. We have already discussed this blue color elements are sim escape. Okay, so if you want to amalgamate or combine both physical system as well as the electrical system, then you need that blue color box elements. But here we are going to build just electrical circuits, so we need this black color source. So just select and right click. Here the option would come add block to model untitled. Just click on that one and you can get this AC source in your main page. Okay, main window. So here is the one voltage source is there. Now there is a need to set the value. So there is an option you can, if you double click this source, there is a options are there. So peak voltage 100 volts. So just keep it up 100 volt. So here 100 volt is coming from this voltage source. Frequency 60 hertz. We are if you would make the system for the Western countries like USA, you need to put 60 hertz. But we are here and we are making the system smart cities for the Indian scenario. So we are just putting 50 hertz supply. Okay. Phase, we don't need any phase delay or anything, and just apply. So this source now become 100 volt 50 hertz supply AC. Okay. Now we need 4 diodes to make the diode rectifier. So simply write diode in the search box of library and enter it. Here again, blue elements are also coming, and the bottommost side, the black color diode is coming. So just take it into the main page, select it, right click and add block to model entitled. So you just get this diode in your main page. Now, if you want to rotate any of the element in the main page, just select that one and give the command Control plus capital R. So I am just giving Control plus capital R. It is moving. So this is the right direction we want for to connect the or to make the diode rectifier. So we want 4 diodes to make a complete diode rectifier. So just right click and copy. Okay, copy option is coming. So just copy that one and Control V, paste, Control V. So whatever the command in Microsoft Word you are using, that is also applicable for this MATLAB simulink. It is very easy. Okay. So Control plus V. So we just get 4 diodes. Okay. Now we can able to make the diode rectifier. So now connect with this, drag this one. This is M, measurement block is there. So if you want to see the waveforms across the diodes, you just need to connect with the scope. We will discuss later. So just connect these 4 diodes with each other to make the closed circuit. Okay. So this is the complete diode rectifier. So we need to connect the coming AC source with this diode rectifier. So connect with one leg, the positive half or the positive terminal of the source, and the negative half or the negative part with the second leg of the diode bridge rectifier. Now we need one load that could be the RLC, RL or purely resistive. But here we are taking the RL load. So just type RLC series, RLC branch. It is automatically coming. So let's see whether it is coming. Just enter that one and it is now come. So just select this series RLC branch and add to your page. So it is coming now. And just rotate again this one by giving the command control plus capital R. So it is like that one. But it is the RLC branch and we want to connect load, or we want to use the load as just series inductor plus resistance one. So that just double click to this branch. So you can see the branch type RLC is coming. Scroll it down and select the RL. So now it's RL, and keep the resistance 10 ohm and inductor 1 millihenry. Okay, and apply to this values. So now it's come to resistance plus inductor branch, and it will act like a load for this rectifier. We also need to connect this load with the circuit. So simply connect, and the second terminal connect to the lower half of the diode bridge rectifier. So it is now connected to the diode. So it is a complete system with a single phase AC source, diode rectifier is there, and load is there. Now, if you want to see the responses of like current, voltage, or anything else in the Simulink, you need a two major blocks. One is measurement block, and second one is the scope. Scope is just like a DSO, like digital signal oscilloscope we are using in the lab to see the waveforms. Likewise, here also you need the scope to see the responses. So the first thing you should have to add voltage and current measurement. So we want to see the voltage coming across the supply. So just write in the library voltage measurement block. Voltage measurement, it is coming. So this is the block. You can measure the supply voltage. Add to the your model. Now it's coming. As we all know that voltmeter, it is just like a voltmeter, and we all know that voltmeter we always have to connect in the parallel with the element. So we just connect with parallelly across this supply, AC supply. Red dotted lines means it is not connected. Still, it is not connected properly with the branch. So we need to connect it and make it black. Okay. So now it's black. So black means it is properly connected. Otherwise, red dotted line means it is not still yet connected to the circuit. Now we again want to see the load current through the RL branch or load current. So just write current measurement block here. Just enter that one. You can get the current measurement block. Add to your system. And we all know that the emitter or the current measurement system always connected in series with the desired element. So we have to connect in series with the load. So it is not connected automatically. So delete it. First connect this current measurement block, this diode rectifier, and the second terminal, that is the negative one, outgoing one, connect to the load. This is this one. Okay. So the I written here is to just see the response to the load by using scope. So this is the current measurement block. This is the voltage meter. We also want to see the voltage and current through these four diodes. So here is already there is a inbuilt measurement block is there. So we don't need to add any voltage or current block with these diodes. We also want to see the voltage across the load. So just copy this one and paste. Okay. And connect across the load. So there are three or four parameters are there. Like we can see the voltage across the grid supply. We can see the current flowing through the diode or load, and we can also see the voltage across the load. Then again, we need the scope, like the DSO in the laboratory. We need the scope in this simulink model to see all the, or to capture all the responses. So just like simply write scope. So this one, and add to your model. Okay, it's already come. So whatever number of inputs you want to make in this scope, you can configure it. Like here, we need one voltage, two voltage, one current, and two diode outputs. So just make it 5 input scope. So just double click on the top leftmost. There is a signal or icon like this. Just double click this configuration properties, make it configure, and we want 5 inputs. So in place of one, just like 5. Okay, and apply. Now 5 inputs come, but we again need to configure in layout also. Just double click, come to this same icon, and layout. We make it 5. Like you can see here, 1, 2, 3, 4, and scroll it down, it will come 5. Now you can observe 5 inputs in this scope. Okay, so just simply connect first one, grid supply voltage, to the first input, the load current, second input, the load voltage as a third input, this diode current and voltage as a fourth input, and this diode and current as a fifth input. Okay. Okay. And one very important thing by building this Simulink, if you want to build a Simulink and you run a Simulink, there is a power GUI block is required. There should be always a power GUI block. Power GUI block means power graphical user interface. So if you put this power GUI block is there, it will run the code behind whatever is this block is showing. Okay, so there is always a coding behind that block, and that need to be run when you run your model. So just like power GUI block, this power graphical user interface block, that is always required with every model of Simulink. You need to put in your model. Okay, so add to your system. This is power GUI block. If you want to configure this power GUI block, just double click this block, and by default it is continuous. So if you want to make your model or your Simulink model, if you want to interface with your real-time system, then you have to make it continuous. However, if you just running the Simulink model like SIL, Simulink in loop, or HIL, hardware in loop, you just keep it in discrete so that you can get more effective and optimized results. You can put the sample time in between 5 to 20 e to the power minus 6. We are keeping here 5. Okay, microsecond. Now your model is ready to run. So just go for this simulation, and this run icon is coming. So you just click to this run. Now you can see the time is going in case, and it is running. So now it's complete 100%. So we want to see the supply voltage, we want to see the current through the load, we want to see the voltage across or current through the diode or voltage across the load. So just simply double click to this scope. You can see a result. And there is a tool, like if you want to expand the x-axis or y-axis, there is a tool here given below. This plus icon is there, scroll it down. So if you want to expand the x-axis, the first option is there. If you want to expand or enhance the y-axis, the second option is there. So just click on the, here we want to just expand to the x-axis. So just click on the first icon and use this to scroll the result, the x-axis, so you can see more clear picture of the supply voltage and current. So you can see the first one is the purely sinusoidal, that is the supply voltage working at unity power factor, and second one is the load current, third one is the load voltage. You can see it is pulsating DC. So by just get taking the AC supply, you are converted into the DC one. If you want more smoother DC supply, you just connect a capacitor in parallel with your load. You can get more smoother DC supply. And fourth and fifth one is the voltage and current through the diode on the simulink. So you can see the blue color is the voltage across the diode and the yellow color is the current through the diode. So in the first half, in the positive cycle, you can see the diode 1 is working and current is flowing through it. Like here, if there is a positive cycle of the supply is there, this diode and this diode will work. If there is negative supply is coming, negative cycle of this supply is coming, then this diode and this diode would work. So you can also analyze by this results. Like in the positive half, the current is flowing through the 1 and 3 diode, that upper half and the lowermost second leg half of the diode rectifier. On the other side, this is the current through the diode D2 and the voltage across when the supply voltage is negative. So these diodes are working alternatively. Like in the positive half, this diode and this diode will work. In the negative half, this diode and this diode would conduct the current. And you can see we can successfully able to convert the AC supply into the DC one. There is one more tool is there. Likewise, we connect this voltmeter to this scope. But there is one tool we don't need to connect so long this voltage measurement tool with the scope. Just delete it and go to the library and type go to and form. Go to and this is form and go to tool. Okay, so just take both into your main window. Okay, so it is very useful tool. You don't need to take such a long connection from the grid supply to the scope. So this is the go to, and if you want to see the supply voltage of this grid, so just connect to here and just connect to here. This. Okay, so you can see the results also go to, and there are a lot of tools are there to optimize your model and all these things are there. So it is one of the example of uncontrolled rectifier. The limitation associated with this uncontrolled rectifier, that there will be a fixed output voltage. You don't have any control on your output supply voltage. Like you have just taken 100 volt and the output would be 100 into 2 divided by 3.14, that is pi. And if you want some desired output, desired DC voltage, then you need to make this system controlled one. Okay. And for making the controlled one, these diodes are also, that's why called the uncontrolled switches. So to make it controlled one, you need the controlled switches. And what are the controlled switches we have in the semiconductor switches? IGBT, diode, IGBT, MOSFET, thyristor, SCR, all things are there. Okay, so just simply take in place of diode thyristor to make it controlled one. So I have one example of that controlled one. So this is the controlled diode rectifier. Okay, I'm not going to make it again. So this is the controlled. We just replace the diode with this thyristors T1, T2, and T3, T4 to make it the controlled one. The rest of the things are same. The rest of the circuits are same. Okay. So to make it controlled one, you have to give the firing angle or gate pulses to these switches to make or to control your output voltage. So like for the T1, if you're taking the firing angle 45, okay, I am first one and demo you the results. That would be the different from the previous one. Okay. So just see This is the supply voltage, and this is the supply current, and this is the voltage. The third one is the voltage across the load. So you can see that we cannot getting the voltage output from the complete positive cycle or the negative cycle. We have a controlled on the output voltage, and this is because of the thyristors we have connected. Of we have to make the diode rectifier by using the semi-controlled thyristors. So you can see we are just controlled the output voltage, and for that one we need the control. So by just putting the firing angle to this switch and this switch differently, this switch and this switch, you can get the controlled output. Likewise, here we are putting for A. So here is the go to, and this is the form block. So you have to make it same. Like you just, if you double click this go to, the name is there A. Okay. So that should be here also A. So both should be same name. So if you double click this pulse generator, so if you want to give the gate supply to this thyristor, you just take the write down in the library pulse generator, you will get this block. So if you double click this is options would come like amplitude, just make one period 0.2, that is the 50 hertz supply, pulse width 0.5, and phase delay 0.0025. So how can you decide this phase delay? Because it is in second, not in degree. It is very important to note it is in second, in time, not in degree. So the thing is that, uh, like if you want a 45-degree firing angle, so what is the duty ratio? So duty ratio is like 45 divided by 360, and that would come 0.125. Okay, and the delay you want to make it the 45-degree, so just divide just by 50 hertz because it is the 50 hertz supply. So divide this number uh, delay. So just divide this number 0.125 by 50. You will get 0. I think 125. Okay, 0.125. So for you want for that one cycle, so just divide 0.125 divided by 360, and you will get the exact delay you need to put into your switch. That would come 0.00, I think 2544. Okay, so this is the delay angle in second for this thyristor T1, and the same value would be given to this T2 because both will work together in the positive half cycle. In the negative half cycle, this T3 and T4 would work. So we need to put the delay angle for this T3 and T4 same. So this is for the T1. This is for the T1 and T2. Similarly, for T3 and T4, again, there's a point 0.166. So you have to calculate that one, the delay angle for that one. The delay angle for 2 is just adding gate 1 delay, There's a simple formula is there. Gate 1 delay plus get 1 delay plus half of the frequency, supply frequency, that is 1 by 2, 50 hertz. Okay. So get 1 delay is equal to 0.0025 plus 1 divided by frequency and 2. Why 2? Because we just want for the 1/2 cycle, not for the 50 hertz, for the 25 hertz. That's for to make 1/2 that of frequency, and that would come nearly I think point 0 1 to 4 or 5. Okay, 1 or 1.0.1 to 4 or 5. I'll just fine. So this is for the gate delay for switch T3 and T4. So like you can see for gate delay T1 it is 0.0025, and for T1 T2 it is 0.0025, and for T3 and T4 it is, yeah, 0.0125. Okay, so 10 is there, so you can simply calculate this fiving. So likewise, if you want to make it 60-degree, 30-degree delay, you can just calculate by using these formulas and you will get the result accordingly. Okay, so you can see there is a control on the DC output voltage. Whereas on the previous case, when we have uncontrolled rectifier, there is a complete cycle of voltage in the positive half and in the negative half. So we don't have any control on the output voltage. But in this case, we are using the controlled rectifier. We have the control on the DC output voltage. Whatever you want the DC voltage, just put it to the fiving angle and you can get the desired results. So this is all about the simulink. You can make any model, any system. If you want, like for battery charging system, you want to make your simulink model, just replace this resistive plus inductive load with the battery. Just go into the library, write the battery, and you can just get into your main model and put it into here. Just see or analyze the charging behavior using the controlled one, and you can make a complex structure for your system by using this simulink. So on the whole, by using both Simulink and MATLAB tools, you can make a very good and very efficient, effective system for your smart cities that could be analyzed before going into the real world, before going to implement into the real world. Okay, so this is all out from my side.
Thank you, sir, for delivering such an informative lecture. With this, we now conclude today's session. We request all participants to kindly join us tomorrow at 11 a.m. for the next session. Please make sure to join on time. Thank you.
Thank you.